T-1 second, the most powerful rocket ever built was already breathing fire, but it did not move. On SpaceX's own screen, 4 engine signals appeared dark. The launch computer shut down the other engines before a fully fueled Starship could leave the tower. Minutes later, Elon Musk admitted that some engines never started. By the next market close, roughly $100 billion in SpaceX value had disappeared. But here is the twist. This abort may have saved SpaceX from a catastrophic launch, while exposing a weakness that could decide the future of Starlink, the Moon, and Mars. This is not simply the story of a rocket that failed to launch. It is the story of a machine that decided launching was too dangerous. On July 16th, Starship Flight 13 stood at Starbase, Texas, fully fueled and carrying 20 experimental Starlink V3 satellites. This was not a routine Falcon 9 mission. It was a test of the vehicle SpaceX believes can transform satellite internet, return astronauts to the Moon, and eventually carry people to Mars. The countdown had already paused at 60 seconds while engineers completed final checks. Then the clock resumed. At 17 seconds, the flame diverter activated. At 3 seconds, the Super Heavy booster commanded all 33 engines to start. From the overhead camera, the pad vanished beneath a cloud of vapor and flame. On the webcast graphic, most engine circles changed state. 4 apparently did not. Almost immediately, the other engines shut down. The launch clock stopped before 0. The tower continued holding a fully fueled 407-foot rocket. SpaceX's Dan Hewitt told viewers the team would investigate what triggered the abort. Musk posted a more direct explanation. Some engines did not start, triggering an automatic launch abort. The vehicle began offloading propellant. Later, Musk said 2 Raptors would be removed and replaced to give the team confidence in the next flight. That is what is confirmed. 4 positions appeared abnormal on the public telemetry. SpaceX has not said that 4 engines suffered 4 independent hardware failures, and replacing 2 engines does not prove that only 2 were responsible. In a tightly coupled launch system, 1 bad reading can be a symptom, not the disease. To understand why, imagine trying to start 33 extreme performance engines within a narrow window while the rocket is still attached to the ground. Each Raptor must receive correctly conditioned liquid methane and liquid oxygen. Valves must move on command. Pressures must settle inside acceptable limits. Ignitors, controllers, and sensors must agree that combustion is stable. Then the launch computer must decide whether the combined thrust is safe. If one engine starts late, reports an impossible pressure, or fails to reach a required state, the system has only fractions of a second to interpret it. The cause could sit inside an individual engine. It could involve propellant conditioning or pressure. It could be a controller or sensor threshold. It could come from ground hardware shared by several engines. Or it could be a timing interaction that appears only when the entire cluster starts together. Until SpaceX publishes its findings, those are possibilities, not conclusions. Anyone claiming to know the exact broken part from a colored circle on a live stream is guessing. What the live stream does reveal is the logic of the abort. A rocket cannot treat startup like an ordinary car engine. Super Heavy weighs thousands of tons when fueled. If it releases the tower without sufficient thrust, the vehicle may not climb cleanly. If unstable combustion damages nearby hardware, a small ignition problem can become a pad emergency. The safest launch under uncertain thrust is no launch at all. That makes the abort both reassuring and worrying. Reassuring because the computer detected an unacceptable condition and shut 29 apparently running engines down before release. The launch mount, tower, and vehicle survived. No one was injured. The protection system did exactly what it was designed to do. Worrying because ignition is the first test every flight must pass. Starship's business case depends not merely on spectacular launches, but on rapid, repeatable operation. A machine designed to fly often cannot require major intervention every time 33 engines meet the pad. Flight 13 matters even more because it is tied directly to Starlink. The vehicle carried 20 next-generation V3 satellites for a suborbital deployment demonstration. They were not meant to become operational satellites. They were expected to re-enter after testing deployment, communications, and imaging systems, but they represented the bridge between SpaceX's current business and its next scale. Falcon 9 built Starlink. Starship is supposed to multiply it. The larger rocket can carry satellites designed around far more mass, power, and capacity than Falcon 9 can efficiently launch. If Starship works, SpaceX can expand the network faster. If Starship slips, the most aggressive Starlink growth assumptions slip with it. That is why Wall Street reacted. SpaceX became a public company in June under the ticker SPCX, with an initial offering price of $135. On the day of the abort, shares finished at $131.11, below the IPO price for the first time. The following day, they closed at $123.99, a decline of about 5.4%. Contemporary reporting estimated that Friday's move erased roughly $100 billion in market value. But blaming every dollar on a 1-second launch abort would be too simple. The stock was already falling. Investors were questioning an extraordinary valuation, watching post-IPO lockup dynamics, and taking profits after a historic listing. Markets do not provide a clean laboratory where one event creates one price. The abort was better understood as a catalyst. It gave nervous investors a concrete image for a risk already buried inside the valuation. Starship is essential to SpaceX's future, and Starship is still a development program. For bulls, the vehicle remaining safely on the pad proved disciplined engineering. Test programs are supposed to discover problems before flight. Replacing hardware and returning within days would demonstrate the speed that made SpaceX famous. For bears, the failure showed that the path to rapid reuse is not yet routine. Flight 12 had already exposed engine relight problems during its mission. Flight 13 then failed during the initial start sequence. Different moments, perhaps different causes, but both point toward the same investor question. How quickly can a prototype become dependable infrastructure? Musk's response followed a familiar pattern. He acknowledged the immediate issue, said 2 engines would be replaced, and pushed attention toward another attempt. The message was not that nothing went wrong. It was that the schedule would absorb the failure. That approach built SpaceX. Falcon rockets exploded, missed drone ships, and lost vehicles before reuse became routine. Starship itself has produced fireballs, lost engines, and returned data from flights that ended violently. SpaceX turns visible failure into an engineering loop. Fly, measure, change, repeat. But public markets change the audience. Engineers can celebrate a safe abort. Traders see delayed capacity, execution risk, and capital tied to a machine that has not yet completed its full economic mission. Both interpretations can be true at the same time. The next attempt will answer only the first question. Can all 33 engines start cleanly? A successful liftoff would not reveal the precise cause of the abort, and it would not instantly settle Starship's reliability. It would show that SpaceX isolated enough risk to try again. The deeper test comes later. Can Starship deploy V3 satellites at scale? Can both stages survive, return, and fly again quickly? Can the company turn the world's most powerful rocket from a dramatic experiment into transportation infrastructure? At T-1 second, the launch computer made the correct decision. It protected the rocket from a flight it did not trust. That may have saved the vehicle, the pad, and the schedule. But for SpaceX investors, the abort illuminated something no valuation model can hide. The future of Starlink, the Moon, and Musk's Mars strategy is balanced on 33 engines starting together. This time, 4 lights appeared to stay dark. The machine refused to fly. Was that a failure? Or the clearest evidence yet that Starship is finally learning when not to launch?